This video is going to cover Chapter 1, Section 5A, which is the Introduction into Complex Numbers. So what is a complex number? A complex number is actually an imaginary number. It's a non-real number. It is used as I, or the letter that's used for a complex number is I, and it is actually equal to the square root of -1. Now we know there is no real square root of -1, so that's why this is an imaginary number. Which means I squared would be -1. Because I times I would be the square root of -1 times the square root of -1, which turns out to be -1. So now we're going to use i's in a lot of different ways in the next section, which is divided between today's notes and tomorrow's. And they include adding, subtracting, or multiplying these terms. And when we do that, we just treat I as though it was a variable like x. When your answer includes, and this should be I squared, when your answer includes I squared, we're going to replace it with a -1. And standard form is A plus BI, which means the real number comes first, and then the part that has the I on it, or the imaginary part, comes second. So for this quick example on the bottom, it says write in standard form 2 plus the square root of -25. So this is a perfect square that's normally just 5, but the negative on the front means I would bring an I to the outside of that root as well. So this would be 2 plus 5i. And standard form again means that the term with the I comes second, so this is already in standard form. Okay, so let's look at all these examples. The directions just say simplify and then write the answer in standard form. So each one's going to be a little bit different depending on the operation. Number 1 says 4 plus 7i plus 1 minus 6i. So with a plus between, we can simply remove our parentheses and combine our like terms. There are two numbers that are real numbers that don't have an I attached to them. 4 plus 1 would be 5. And then there's two numbers that also have an I on them. 7 minus 6 would be a positive 1i. Now we don't need the 1 there, so this could just be 5 plus I. Again, always putting the I at the end. Number 2, same thing. It's addition, so we can just ignore the parentheses. 1 plus 3 would be 4. Positive 2i and negative 2i would cancel out. So my answer here is just 4. Number 3, I've got subtraction signs in front of these parentheses, so I'm going to distribute. 3i minus a -2 would become plus 2. Negative times a 3i would be minus 3i. And then this negative also gets distributed, minus 2 minus 5i. Now we combine our like terms. I'm going to put all the real ones first. Positive 2 and -2 are actually going to cancel out. And then positive 3i, negative 3i cancels out. The only thing left is negative 5i. Number 4 has addition and subtraction. So with the addition, I'm going to take off the parentheses. The subtraction is going to get distributed. And then I'm going to go through and combine all my real numbers. 3 plus 4 is 7, minus 7 cancels out. And positive 2i minus I would be positive 1i minus another I. Means everything has canceled, leaving you with just 0. Number 5, we've got multiplication. So we want to distribute that 4 to both terms that follow it. I'd get 4 times -2, which is -8, and 4 times 3i, which is a positive 12i. Already in standard form, so I keep it that way. Moving on to number 6. Now we've got two binomials next to each other, so we're going to FOIL these out. 2 times 2 is 8. I'm sorry, 2 times 4 is 8. 2 times 3i is positive 6i. Negative I times 4 is minus 4i. Negative I times positive 3 is negative 3i squared. So now this is the first time we have I squared in our expression. I squared gets replaced with -1. So this would be negative 3 times negative 1, which actually becomes plus 3. I'm going to do that again. So the I squared gets replaced with negative 1. Negative 3 times negative 1 makes this a positive 3. Now my real part is 8 plus 3, which is 11. And then the two terms that have I on them, 6I minus 4I, would be a positive 2I. Seven, again, we're foiling. So 3 times 3 is 9. 3 times negative 2 is negative 2I is negative 6I. 2I times 3 is positive 6I. And 2I times negative 2I is negative 4I squared. My 6I and negative 6I cancel out. This becomes negative 1, making this a plus 4. And my answer is just 13. Now I go to 8. What I cannot do is distribute the exponent. We are going to expand and FOIL this out. So 3 times 3 is 9. 3 times 2I is 6I. 2I times 3, 6I again. 2I times 2I is 4I squared. The I squared becomes negative 1, and now this becomes minus 4. 9 minus 4 is 5. Positive 6I plus 6I is a positive 12I. Number 9, we're back to foiling. 2 times 3 is 6. 2 times 3I is positive 6I. Negative 4I times 3, negative 12I. Negative 4 times positive 3I, negative 12I squared. I squared becomes negative 1, making this a positive 12. 6 times 12 is 18. Positive 6I, negative 12I, negative 6I. Okay, now we're going to talk about a conjugate. So the conjugate of a complex number is the same terms, but the minus or the plus that's in between it changes. So it's the same terms. If it starts positive, then it becomes a negative. If it starts negative, it becomes a positive. The sign in between them, or the sign that is on the complex part, or the I. When you multiply a conjugate by the original complex number, the I disappears. And the shortcut for this would be A squared plus B squared. So if I multiplied 2 plus I times 2 minus I, the A is the 2, so I'd get 2 squared. The B is what's in front of the I, so not the I itself, what's in front of it, which would be a positive 1 here. And then I'd square it, 4 plus 1 would be 5. So that's the shortcut. If you forget the shortcut, you can always go back to foiling out what you were beginning with. All right, so numbers 10 and 11 say multiply by the complex conjugate. First thing we have to do is figure out what the conjugate is. So if it's 1 plus I, then the conjugate would be 1 minus I. Two choices, FOIL this out. 1 times 1, 1 times I, 1 times negative I, 1 times I, and I times negative I, which would be negative I squared. The I squared becomes negative 1, and minus a negative 1 becomes plus 1. And I end up with 1 plus 1 or 2. These cancel out. So the shortcut here, 1 plus I times 1 minus I, is A squared plus B squared. The A is what's in front of the term that doesn't have the I on it, so it's just the 1. And the B is what's in front of the I, which again is a 1. 1 squared plus 1 squared would be 1 plus 1, which is 2. So as you get more comfortable with the shortcut, obviously it's going to be faster. But if you forget, you can always go back to your original and FOIL it out. All right, let's look at 11. This is 4 minus 3I, so the conjugate here would be 4 plus 3I. Now let's try our shortcut. A would be 4 squared. B would be 3. Now the sign doesn't matter because it's going to be squared, so it would always go away anyways. and then I put a plus between them. 16 plus 9 is 25. So this is why conjugates are important. When we're dividing with complex numbers, if there's an I in the denominator, we're basically saying there's a square root of a negative number in the denominator, and we can't leave square roots in the denominator. So we multiply both the top and the bottom by the complex conjugate of the denominator. So whatever's in the denominator, we're going to find the conjugate, and then we're going to multiply both the top and the bottom by that expression. All right, so the examples will look like this. Number 12 says 4 over 1 minus I. So the conjugate to 1 minus I would be 1 plus I. And I'm going to multiply both the top and the bottom by this. So my numerator is going to get distributed. 4 times 1 would be 4. 4 times I would be 4I. And the denominator, we're multiplying conjugates, so you can either FOIL it out or use your shortcut. 1 squared plus 1 squared, 1 plus 1, which is 2. Now, if you can reduce this, you need to. So all 3 of these spots have to be divisible by the same thing, and they are. They're all divisible by 2. So 2 goes in here once, twice, and twice, and I end up with 2 plus 2I. Number 13, my denominator is 1 plus I. So I multiply times 1 minus I. FOIL out my numerator. 1 times 1 is 1. 1 times I, negative I, or 1 times negative I, sorry. Negative I times 1, negative I again. Negative I times negative I is a positive I squared. That positive I squared becomes negative 1. I'd get 1 minus 1, so those cancel out. And I have negative I minus I, which is negative 2I. That's my numerator. Denominator, shortcut, 1 squared plus 1 squared, 1 plus 1, which is 2. And then again, this gets simplified to just negative I. Okay, we're going to do 14. So the complex conjugate would be 4 plus 2I. In my numerator, I'm going to FOIL it out. 2 times 4 is 8. 2 times 2I is 4I. 3I times 4, 12I. And 3I times 2I, positive 6I squared. I squared gets replaced by negative 1, and this becomes minus 6. So my numerator, 8 minus 6 would be 2. 4I plus 12I is 16I. Denominator, A is 4, B is 2, so 16 plus 4 is 20. Again, all 3 of these spots can be reduced by 2, and I get 1 plus 8I over 10. Now we're going to save numbers 15 and 16 for the start of class tomorrow so we can review it, so you can hold off on those. Let's look at some negative square roots. So remember we said when there's a negative underneath the square root, we need to pull that negative outside of the square root by putting an I on the outside. What's important is we want to make sure we pull the I out before we simplify anything else. So for some of it, that's the only step you're going to get to do, but then there's going to be some where you're combining terms and you want to make sure that you take I out first and then simplify. So if we look at 17, I cannot simplify the square root of 3, but I can take the negative out by making it I square root 3. Now normally we put the I at the end, so you can also rewrite this as square root 3I. Just be sure that you don't put the I underneath the square root. So I would take either format there, so will WebAssign. I actually prefer the I in front so you don't make the mistake of putting it underneath the square root, but both of those are correct. Looking at 18, now I can actually simplify 16, or the square root of 16 would be 4. Take out that I, and I'd get 4i. When you look at 19, I would take out the I, and I'd get I times the square root of 48. Not a perfect square, but 2 and 24, 2 and 12, 2 and 6, 2 and 3. I bring one pair of 2's to the outside, a second pair of 2's to the outside, and the 3 stays underneath. So this is 2 times 2, or 4i square root 3. Looking at 20, I want to take the negative out, so I square root 500. This is 5 times 100, which is 10 and 10. I can continue to break that down, or the 10 and 10 repeats, so it can come to the outside, and I get 10i square root 5. And 21, I take the I on the outside. There's already a negative there, so this would be negative I square root 80. 80 breaks down into 2 and 40, 2 and 20, 2 and 10, 2 and 5. There's a pair of 2's, a second pair of 2's, and the 5 that stays underneath. So I would rewrite that as negative 4i square root 5. All right, here's some more examples. So we're dealing with the square roots here, and this is when it's important to make sure you take the i's out first. So think about what would happen if I just multiplied that straight across. I'd get the square root of negative 7 times negative 7, which is actually the square root of 49, and that's 7. And that is wrong. What you need to do is take I out first, and I'd get I square root 7 times I square root 7, which becomes I times I, or I squared, square root 7 times square root 7, which is 7. I squared is negative 1 times 7, and my answer, which is the correct one, would be negative 7. So again, you want to make sure you take I out before you simplify. So looking at 23, I could take the I out, and I get I square root 6 times I square root 10. I squared times the square root of 60, which you can try to break down, 2, 30, 2, 15, 3, and 5. You could have also kept them separate here and combined them underneath the square root to save you that 6 times 10 step. I can take out a pair of 2's, 3 and 5 stay underneath. The I squared becomes negative 1, so I end up with negative 2 square root 3 times 5, which is 15. Okay, looking at 24. So we can simplify the square root, but we want to take the I to the outside first. So this would be I square root 20 over I square root 2. And then both of these numbers are underneath the radical, so I can actually divide 2 into here and 2 into here. And the i's can cancel because it's in the top and the bottom. So I end up with square root 10 over I, which is gone, square root of positive 1, which would just be 1, and my answer is just square root 10. Now 25 only has the negative in the top, so I want to take the I out first. Square root 48 over square root 24. 24 goes into itself once and 48 twice, and I end up with I times the square root of 2 over the square root of 1, which is just 1. Okay, we're going to save 26. 27, and 28 for tomorrow. Let's look at 29. So I'm going to take I out of the square root 12. I'm going to take I out of the square root, negative 6, sorry, negative 12. And square root 8 stays in the bottom. So I can group together both i's, it'd be I squared. I can group together the 12 and the 6 underneath the root and the square root of 8 in the bottom. Now I can break this down any way I want, but if I multiply out 12 times 6, I actually end up with 72. And because they're both underneath the root, 8 goes into itself once and into 72 times 9 times. So I'd end up with I squared, which is negative 1, and the square root of 9, which is 3. Negative 1 times 3, which is negative 3. Okay, a couple more examples we're going to do here, and then we'll save one for tomorrow. So 30, I'm going to take the negative out from underneath the square root of negative 128. So I got negative 8. That's a times I square root 128 over 4. Now, because this is multiplication here, I can actually take, and this is all one term, I can divide the 4 into the 8 2 times. So I can start with that already and do negative 2I square root 128. That's 2 and 64, which is 8 and 8. So the 8 repeats. I can bring it to the outside, multiply it times the negative 2 that's there, and I get negative 16I. The only thing left under here is square root 2. Now that's different than 31. 31 has a plus in between these two. So I can't simplify the 3 into the 9. I want to take the I out from underneath the square root of 18. 18 is 2 and 9, which is 3 and 3. A pair of 3's goes to the outside. And I have negative 9 plus 3I, the 2's left underneath, over 3. 3 goes into itself once, and 3 times. And I end up with negative 3 plus I square root 2. All right, we're going to save 32 for tomorrow. And we're going to look at our last set of examples, which is i's to the highest power. So you will see these are great standardized test questions. Something like I to the 27th, which if you multiply it out, I times I times I times I times I 27 times, and then go through and find every grouping of 2 and replace it with negative 1, you could get to your answer. But there's also a bit of the shortcut. So remember that I squared is negative 1. We want to take all of our terms and rewrite them in terms of I squared. So I'm actually going to start with 34, and then I'm going to go back. Well, let's do 33. This, as if I just expanded it, would be I times I times I times I times I, 5 times. I times I is negative 1. I times I is negative 1, and then I have an I without a match. And then we'd multiply this all together. Negative 1 times negative 1 is positive 1 times I is just a positive I. So when it's a smaller number, like just to the 5th, it's not so bad to do it that way. But when we get to something like 34 and it's I to the 32nd, instead of writing out 32 i's, what we want to do is rewrite this exponent in terms of something squared raised to a power. So I would rewrite it as I squared raised to, now to figure out what goes on the outside, I'm just going to do 32 divided by 2, and I'd get 16. So if you think about this in the reverse, if I was to raise a power to a power, I would multiply these two numbers out, and I'd get back to that 32. So I'm doing I squared to the 16th. Now I squared is a negative 1. And think about what happens when you raise a negative to an even power. That negative goes away. So negative 1 to the 16th is just a positive 1. Now it works easy when there's an even number there. When there's an odd number, like 33, the first thing we want to do is split this into an even number and then the I. So I to the 32nd times I to the 1st is I to the 33rd. So we can rewrite it as that. Then take the even power one, I squared raised to the 16th times I to the 1st, or just I. We already said this would be negative 1 to the 16th times I, which is 1 times I, which is just I. Now look at 36, I to the negative 16th. There's a negative in my exponent, which means I put this as 1 over I to the 16th. This would be 1 over I squared raised to the 8th, or 1 over negative 1 to the 8th. Again, I've got a negative 1 raised to an even power, which is just going to go back to positive 1, and my answer here is 1. We're going to do one more, and then we'll go back to 38 tomorrow. So 37I to the negative 101 would be 1 over I to the positive 101. I'm going to pull off one I, so it would be I to the 100 times I, which is 1 over I squared to the 50th times I. 1 over negative 1 to the 50th times I is 1 over 1 times I, which is, I'm working backwards over here, 1 over I. Now I cannot leave the I in the denominator, so I can rationalize this. So 1 over I. The conjugate to positive I would be negative I. I multiply that in both the top and the bottom. 1 times negative I is negative I. Negative I times positive I is negative I squared, which is negative 1, and the denominator becomes positive 1. So this is negative I. And then we'll save 38 for tomorrow. That wraps up the notes. So take a moment to submit your notes to today's assignment. And you're going to use the remaining time to work on your 1.5A homework. A quick note on the WebAssign formats. So when you have questions like the ones where we rationalize the denominator, and you had something like 2 plus, well, actually, even if it was just 2 over, no, it would be, sorry, 2 plus 3i over 5. Let's say that that was our overall answer. WebAssign actually wants this answer split up into 2 over 5 plus 3i over 5. So if you want a green check, it's got to be split like this. Now, if you leave it like this, I'm fine with it. On the test, it will be given full credit. So it's fine to leave it like that. But if you want the green check on WebAssign, and I know it's so important to a lot of you, then anytime you've got a fraction like that, you're going to split it up. So if it was 5 plus 17i over 24, I would split that into 5 over 24 plus 17i over 24. Again, just a formatting thing that WebAssign is particular about, but I am not, so feel free to leave it the other way. Have a fantastic day, guys, and I will see you tomorrow.